How's everyone doing? We're not starting yet. We'll get started here in a second, but can you hear me and see me now? The latency problem is fixed. I'm using custom. Dan, good to see you. Dan, I can hear and see everybody now. I'm back from the future. I am back from the future. Oh my gosh, so amazing to be back. Real Time Brian is back. And you know who else is here? He missed you. He's here. We said he'd show up last class. So good to see you, Kobe, right there. So what can we have with us for the exam? Calculator, your scratch sheet of paper, and your formula sheet. But, you know, he missed everybody. Let's go back here. Oh, no, I'm not quick enough.
I'm Tiny Brian. I missed everybody. Brian of the future wouldn't let me visit class. He'll be back. Let's go back to Brian. Okay, here we go. He's coming back now. Tiny Brian.
Okay, I'm back now. So we've everything fixed up. There we go. Tiny Brian's back. It's so good to have the chat going normal again. Sorry about that. They've updated something on Streamlabs. I don't know what they did to it. They care more about Twitch than they do YouTube. And so a lot of people stream on, oh no, we're totally doing Kahoot. Oh, we're going to get Kahoot going. Let's get the Kahoot going in the background right here. But everything's going good. We're going to get the Kahoot going. You know, there's lots of prizes today. So let me get the Kahoot up and going. So let's check this out. If for some reason the Kahoot gets crashed, we will, whatchamacallit, we'll post this thing. I can't even think. We'll post the code to our usual spot, but we're going to try to play the Kahoot by posting the code here. It just makes it easier since we have a lot of people in a lot of different classes. And so I'm getting the Kahoot up and going. And so let's get that Kahoot music going. Oh, that's loud. That's loud. You can't hear it yet, though. It's spooky Kahoot. You know what? In honor of Halloween, best holiday of the year, we're going to hear some spooky Kahoot music. Oh, it's really scary. It might be too scary. So let's see. Should we hear the spooky Kahoot music? You can hear it anyways. Let's see. Here's the Kahoot music playing now. We got it. We are good to go. There should not be lag, Alexander. So we should not be lag. Are we all good? Spooky. Game pin coming here in just a second. Brielle is excited. That's awesome. Can you hear the music? They have so much good music on Kahoot. It's like, I don't listen to K-pop anymore. I just listen to Kahoot. Sorry, K-pop. Let's do a quick latency test. You ready? I want you to get ready to type snap. Or you can just type 1. But when you see me snap, or when you hear it, I want you to type 1 in the chat. So we're going to do a latency check right now. Here we go. You ready? Have 1 ready to type. Just type 1. But don't type it yet. Just type 1, and here we go. 3, 2, 1. There you go. There was the snap. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. There we go. We're on like a 5-second delay. Should be good. Make sure you're up to date on the video. So get ready to play right here. Snap. I love it. Okay, so we're going to try to do the usual thing. How many people do we have watching? We're not going to start the Kahoot till 6. 6 your time. 5 my time. We will have an awesome Kahoot. Lots of fun. Great stuff. How many people do we have? 56. Snap, crackle, pop, Rice Krispies. Great stuff. 5-ish delay and pretty standard. Yeah, exactly. I think there's 26 questions on the Kahoot. 25? I'll show it in a second here, Annette. And we're back to normal latency. So beautiful. So beautiful. One thing you can do is you can kind of restart the video. You can leave and come back. Just make sure you're kind of watching as live as possible. Some questions are 30-second questions, which means you have 24 seconds. So you lose a few seconds because we do it over the internet. But it's more fun. Do it over the internet. So then you can watch it. You can review. So good to have everyone here. Ashlyn, Ivan, Evan. So good to have you. Stevie, Destiny, Rocky Top. So all the positivity. What do we have going on? Could have played some sad music. The whole last stream was literally just pure and utter. Do I have it on here? I do. It's like sad happy though. Let's go back to spooky. Back to spooky. No more sadness. Sad Brian. What's sad Brian?
This is not sad, Brian.
So, no, we'll do it right here because I think most people are used to this. Twitch was kind of my backup, and I think people get confused. Oh, thank you, Stevie. I'm glad that helps out. I'm glad that people are a lot less scared. And I'm hoping, you know, the reviews are kind of fun. There's 40 points on the line right there. And so, you know, I'm hoping that, you know, people have some fun and enjoy the review. It's kind of our goal. Have fun, learn. That's what we do. So we will do this. So are there any last questions? Or we're going to start in 3 minutes. 3 minutes. Ask your questions right now. Are you still in the future or not? No, I'm not in the future. I'm only 5 seconds in the future. Thank you, Joseph. Really glad to hear that. It's just, when I went to school, it was so boring. Sorry, people. But who wants to sit in a class and just not have fun? And I thought to myself, here's a quick story. When I was in 12th grade, I got to do a Spanish class for the day. And we got to play El Fuego. Fire. And I can't remember how to play El Fuego, but it's a Spanish game. If someone tells me the rules of El Fuego, I'd love it because it's the game I got to do. And so I thought to myself, why can't every day be fun? Like today we're learning, we're having fun, and we're just, you know, going through reviewing Spanish. Me gusta español mucho. Muchos años pasado yo trabajé en un restaurante. Muchos años pasado. But I was like, why can't it just be fun? And so I try to make class every day fun. Try to do some craziness. You have to break it up. You can't just be like serious. You have to be like, okay, let's have a little fun here. Let's do something fun. That's why I wear my t-shirts. I like my t-shirts. They feel more comfortable wearing dress shirts. So we got this right here. So be in the chat for bilingual Brian. I used to be decently bilingual. Like I probably shouldn't even say that. Like because we're here in Texas, we heard a commercial in Spanish, and I knew parts of it, and like I knew, but it's so hard because I talk fast and everyone talks fast, and then when I would speak Spanish with people, I'd be like muy despacio, no rápido. Like I'd be like, please talk slowly to me. I need, because I don't know, I got different. Brian cuts his hair. The haircut is coming soon. Thursday's class. Get ready for some fun on Thursday. Got to get up early. Gotta talk to the Joker. He should be attending class as long as everything. Oh, but you come to office hours on Thursday. The outfit only works one time because I have to put like halfway prosthetics, not real prosthetics, but some I bought. Have you heard of Hades? Yeah, that game looks awesome. Destiny, that's really good advice right there. Hades looks really good. I should just go buy that for the Switch today. I should just, because I've been playing Isaac so much. So not Wednesday because I kind of want to do it all day. And we'll post the Kahoot here and let's do it. Okay, so if we get Kahoot botted, we're going to put the code where it usually goes. And either, you know, we just want to make the Kahoot happen. So don't break the Kahoot because then it's no fun. This is no fun. I used to play Minecraft back in the day. Let's show the code right here. The code's up. Boom. Code is up. Code is up. Well, thank you, Joey. I appreciate that. So Minecraft's a fun game. I had a castle to Captain Planet because he's our hero. Gonna take pollution down to 0. I'm an 80s kid. So Captain Planet, good guy right there. And so I built this whole big thing in Minecraft. And I had the classic thing where you build a huge pipe that you can jump down to the center of the world. Oh, it's so cool. It was, you gotta have that pipe where you have to put the pool of water at the bottom. So you build something all the way up to the top of the sky, and then you jump down to the bottom. And then I think I made like a lava, like a glass thing of lava. And I can't remember what else I did, but see, I should boot up my Xbox and look at my Minecraft world. I don't think it transferred over to Xbox. I played that on, I think I played it on 360 first. Welcome to the, I have no idea what that means, Pain. So, I should play Among Us. That'd be really fun. I think my fiance and I could play Among Us and have lots of fun. Like we should have like a Statue 1 competitive Among Us. What if we did that? What if we analyzed the analytics on it? What if we could do that? You know what? Let's try to make that a goal. We have a stats who won Among Us. We could do it on Twitch. So one of these nights, I should do a stats who won competitive Among Us. And so then we will analyze the variation. You'll have to put in a sheet. You've seen stuff like that. They analyze the variation. So then we try to see like what is the best strategy. And like we could have people, you know, say the strategy they did. I would need some help with this. Like the most deadly rooms. What room did you die in? Because I've seen that. I've watched about this much Among Us. So I know a little bit about it. Yeah, where are you most likely to die? And then you just avoid those rooms. But then that'll change the process. That might change the process because people have that information. We'll get started here in 2 minutes. So boot up if you're ready. There's actually a button on the home screen that shows you individual statistics. That's cool. Gotta love the stats. Who is most likely to be the imposter? Yeah, doesn't it shuffle around? Back of electrical. Ooh, don't go there. So you have to go into certain rooms, to do the tasks, right? Let me hit the button here. Let's put it to the 1 minute countdown. 1 minute countdown is going, so get ready to join up. Love it that we have 100 people here. You want to completely random for imposter, yeah. It's kind of like people who tell me there's a strategy for winning the lottery. There's a strategy for playing it, I'm sure, but not a strategy for winning it. Strategy for playing the lottery is just don't play the lottery. We've got 40 seconds till the Kahoot. 40 seconds till Kahoot coming up. Big review right here. I have no idea what's going on. So, yeah, we should definitely do something like that. We could have a big Among Us tournament. Stats 201 Among Us. Should get Peyton Manning. Peyton Manning join us in on Among Us. That'd be awesome. He's a busy guy. He's a busy guy. He's doing his thing. He's doing his thing. So, I'd love it. It'd be so bad. You lose to Peyton Manning in Among Us. I mean, he's one of the greatest of all time. So, Dynamic Otter. You got it, Dynamic Otter. Oh, it's class time. It's ready to go time. So he was here like 2 weekends ago. Oh no, sorry to hear that, Florence. Use the Discord to start. That's the thing. Here we go. The Kahoot will be about 45, 50 minutes, I think. Are we ready? Let's see some I'm ready's in the chat. Some I'm ready. I'm ready. I'm ready. I'm ready. We're not on a delay right now, so I should start seeing some I'm ready's. Because here we go. We got Connor ready. We got Zane ready. We got Victoria ready. We're starting. Remember, it's $40 for first prize, $20 for second prize, third, $10 for third, 40, 20, 10. That's the order right there. SpongeBob, you know what's going on. Let's start this Kahoot, and we're going to lock the game in 3. Get in here. 2, we're locking the game. 1, game is getting locked. Game's locked. Okay, let's do this. Wait, where's my button? There we go. Tiny Brian's here. First question. I probably need to make Tiny Brian. The probability of getting a multiple choice question correct with 5 questions. Oh my gosh. This is a tough one. Do not click immediately. With 5 questions, what is the probability you get at least 1 wrong? So I'm going to walk you through this. You either get all the questions right or you get at least 1 wrong. So think about this. What is the probability of getting all the questions right? So you get the first right, and you get the second right, and you get the third right. So you get the first right, second right, third right, fourth right, and fifth right. You get all the questions correct. So either you get them all correct or at least 1 wrong. I'm going to halfway cheat on this one so you can see the answer while we do it. So what is the probability of getting the first right, and then the second right, and then the third right, and then the fourth right, and then the fifth right? And that is not the answer. Because that's the probability you get everything right. So either you get everything right, or you get what? So think through this. This is a big one right here. Sorry to start off. It's randomized on what we get, I think. So we got a really hard question to start here. But people might be seeing the answer. Well, you could get 1 wrong. Either you get all 5 right, or you get... Can I highlight? Oh, I can. Either you'll get them all right, or at least 1 wrong. And the answer is kind of on screen. This is not the answers. 3 of the answers are an imposter. And so what must you do with this answer right here? Because this is the probability of getting them all... Wait a minute, did I do it wrong? Yes, because either you'll get them all right or at least 1 wrong. I think we've done it. Because either you'll get them all right. This is everything right. You get the first right, and the second right, and the third right, and the fourth right, and the fifth right. Andrew, nice job in the chat right there. There's the answer. We worked through these problems. I try to work through them as we talk right here, so you do get hints as it goes on. Please tell me I put the right answer in the chat. Let's see that blue answer appear. Boom, blue answer right there. Great job. Good practice. Remember, you get them all right or you get at least one wrong. So what is the probability that you get them all wrong? Can you show us how you did that in a Word document? Yeah, let's go to the Word document right here. So we can use something very similar to what we were doing here with the jelly beans question. So this is the jelly bean question, but with more things right here. So when we look at this, what is the probability? At least one wrong. So the probability of right is 80%. The probability of wrong is 20%. So at least one wrong. So when we look at this right here, so let's take a look. Either you get everything right or you get at least one wrong. What is the probability right here of getting them all correct? What is the probability of getting them all correct? So either you get them all correct or at least one question is wrong. The probability of all of them correct is this, and I think we figured out 0.32768. And then the probability right here is just showing how we got this right here. Oh, sorry. Is this making sense? Who thinks they have these at least one problems down a little bit? Who thinks they have these at least one problems down? This is a tricky one, a really hard question to start, and it should be 6723, I believe. 67232. So why would it be 1 minus 0.8 to the fifth? Because this is the probability of all of them correct. It's everything but getting all of them correct. One is everything, and everything but getting all of them correct would be at least one wrong, because either you get them all correct or you get at least one wrong. The complement of everything correct, which means 0 wrong, is at least one wrong. So either you get everything correct or you get at least one wrong. And we could say this right here. So think about it as this way. You either get everything correct or you get at least one wrong. Does that make sense to see it right here? You either get everything correct or at least one wrong. So then we're just going to take and bring this over to this side and just subtract for the probability of this. If you did 0.2, 0.2 would be all wrong. So this right here would be the probability of all wrong, and this would be at least one right. So this right here, we're going to see right here. And this is the probability of at least one being correct. So either you get all 5 wrong or at least one is correct. And the probability of getting at least one correct is going to be 2, 3, 4, 5, 6. Oh my gosh, I did it wrong. There we go. 2, 3, 4, 5. There we go. And 1 minus. So that is the probability of at least one is correct. So it's super, super likely you'll get at least one correct. But does this make sense right here? Now I've solved for the probability of at least one right, which is everything but getting them all wrong. So 1 minus 0.2 to the fifth power would be the probability of getting them all wrong. Everything but getting them all wrong is at least one is right, because either you get them all wrong or you get at least one correct. Does that make sense right there, Rocky Top? Really great questions. Good. We're going to see who's on the leaderboard. Who told me their name? Someone told me. I need to root for them. I don't know who it is, but let's see if they're on the leaderboard. Smiling Elk and Knowing Zebra. Woo, Smiling Elk. That must have... Smiling Elk. And we got Rocky Sable. Really great answers, but did they know the answer or did they just answer quickly? Let's find out with the next question. Why can't we do 0.5? Because then it'll be the probability. It's everything but getting them all wrong. So that would be at least one correct. So that's Dynamic Otter. Dynamic Otter, I want to see on this leaderboard. Let's find out right here, Dynamic Otter. 2 events that can be easily added together are what? 2 events that can be easily added together. And this goes back to the addition rule. We got some notes on this that we can show here in a second. But when we can add together 2 events, they must be what of each other? Lots. I think a lot of people know this. So there's 2 words on here that are right answers. 2 words that mean the same thing. It's not... Dependent is not one of them. Dependent and independent are opposites. But disjoint and mutually exclusive. Ooh. Oh, no. Oh, no, no, no. Not no, no. Joseph clicked wrong. Oh, no, don't misclick. Let's take a look at our notes on this. Let's take a look at the notes. So we've got some notes. Here's the notes. So we have here the word disjoint is with the addition rule. So the word disjoint right here is when we say or and we add things together. So when two things can be easily added together, they are disjoint. So two disjoint events are when if A happens, B cannot happen. Can anyone give me two disjoint events in the chat? 1,000 points for just being here. So can anyone give me two disjoint events? I'll open it back up here in a second. Can anyone give me two disjoint events? Can anyone give me two disjoint events? Can anyone give me two disjoint events? Coffee, going to school in the morning. Those would have a joint because those can both happen. Because you can go to school in the morning and get coffee. Living in both Nashville and Knoxville. Imagine someone says, "What is your home address?" Like your permanent, like where your permanent home address is. Acing and failing a test. Yes, because if you live in Nashville, you can't also live in Knoxville, like your home address. Like if I say, "What is your home address?" and you're like, "Knoxville, Nashville," and you're like, I'm like, no, what is your home address? Getting A's or B's in the same class. You can't get an A this semester and a B semester and a B in the same class, like in the same semester. Turning left and turning right at the light. You can't turn left and turn right. So this is the idea of disjoint right here. This is disjoint and this is not disjoint. So if there's an overlap where A and B can occur, like there's an A-B time where you could get coffee in the morning and go to class, then getting coffee and going to class are not disjoint. So this is not disjoint. And if things are disjoint, we can easily add them together. So really good review slides right here. Wearing a mask, not wearing a mask. Either you're wearing the mask or you're not wearing a mask. So wear a mask properly too. Cover nose. So I should show you guys one of my masks. I got some pretty cool ones. I got a Spider-Man one. I got a mustache one. I got a Star Wars one. Everyone's like, "Oh, do you love Star Wars?" I'm like, no. Chelsea and I have decided that the next time someone asks me if I like Star Wars, I'm going to be like, "Yeah, Spock's my favorite character." And I'm just going to like leave it at that. I mean, they're just being nice. I shouldn't be rude to them. Tiny Brian and regular Brian. Yeah, you can only be Tiny Brian and regular Brian. You got it. Having a mullet or not having a mullet. There we go. Ooh, smoothing elk. Destroying it. But we got two knowings behind you. Knowing zebra and knowing lark. Tough competition. Dynamic otter. Come on, Dynamic otter. We're all rooting for you right here. Let's find out the next question. Who's going to win? Two events that have no influence on the probability of each other are what? Two events. Dynamic otter. You got this, Dynamic otter. Where are you going to be? Where are you going to be on that leaderboard? I say you're going to be in 4th place after this. So when two events do not influence each other, they're definitely this. It is by definition, if you know A, and then it tells you nothing about B. Like I'd say, I know Brian got coffee this morning, which I didn't. But does that tell me anything about Peyton Manning getting coffee? It'd be independent. Nice job. Nice job. That's what independent means, is they have no influence. Nice job. I'm cool with that. I'm fine with that. We did great. That's just a total, oh man, awesome right there. Love it. So if we know Brian got coffee, does that tell you anything about Peyton Manning getting coffee? I think they're independent. So completely independent does not give you any information when we know something. So what can we do with two independent events? With two independent events, we can multiply them together. That's the wrong thing. With two independent events, we can multiply them together. So knowing A tells you nothing about B. So if I say Brian is from New York, then would that tell you anything about where you're from? Probably not. If you know Brian teaches at the University of Tennessee, then that might give you information. But you say Brian's from New York. Does that tell you anything about where so-and-so's from? Unless they're related to Brian, probably not. Because now if you ask where's Brian's brother from, then that's going to give you information. So where Brian's brother is born is probably dependent on where Brian's born. Now that doesn't mean you know Brian's brother's born in New York. You would know information because where someone in a family is born would kind of be dependent on where other people in the family are born because they're a family. So that's the way it works. That's what independent means, and we can multiply two things together. Like let's just say this right here. The probability of someone being from New York at UT is 1%. So probability of someone being born in New York is 1%. What is the probability that the next two people you run into at UT are born in New York? Like you walk outside and you say, "Hey, I just want to know where you're born." They're like, "That's weird, but I'm born in New York." So what is the probability the next two people you run into are born in New York? And you wouldn't want to talk to two people walking together because then they might have dependent probabilities. But you talk to two random people. You talk to a person and then you say, okay, go away. I need to talk to more people. 0.01 squared or 0.01 times 0.01. So this is the first person was born in New York and then the second person. And you see me saying the and word right here when we multiply. So that's it. Nice job, Andrew. Great job practicing. We can multiply together two events. Nice scientific notation right there. I got to practice. Yep, that'd be right. No, I think it's e to the negative 3, e negative 3, Victoria. I think it is, right? Because it'll be no, I think my brain is just broken. Yeah, I think Victoria's right. Victoria, 1,000 points right there because I misspoke. Victoria, you're right. I should never question. Yep, that's right. Oh my gosh, what happened to the leaderboard? Oh no. I don't know if Mubot's counting those errors or not, but Dynamic are greater than everyone except Brian and Tiny Brian. Tiny Brian's the best. He's the best. Broken Brain Brian. That's some alliteration right there. I love it, Andrew. So continuing on, we got Smoothing Elk or Smiling Elk in the lead. Continuing on, question number 4. To multiply the probability of A and B, these two events must be what? This is now a review question. This is now a review question. This is now a review question. These two events must be what? I like to do a lot of review questions. You should know pretty quickly. It's on the formula sheet too, that when we multiply two events, they must be this of each other. Now, it's not the addition rule, which says they must be mutually exclusive or disjoint. Mutually exclusive and disjoint are the same words. If we're going to multiply two events, they must be this of each other. Boom, right here, independent. Pretty good job right there. Remember, independent is the multiplication rule. Take a good quick look at the sheet again. It's a good cheat sheet that we have right here. There it is. So the multiplication rule is independent. So the multiplication rule is independent. Make sure to do the independent. Wasn't that basically? Yeah, it was. I do a few review questions to make sure people kind of know this and because you have to practice something 3 times. Oh, Victoria, you got this. Here, I'm going to pick someone to root for. We're going to have harder questions coming up. Oh my gosh. You know I'm a fan of it. I like bunnies. Bun's out there. Morty's out there. So for Morty, Focused Bunny is our new favorite because Morty right here. Love some SpongeBob in the chat. Next question. Let's do this. Question 5. Ooh, we got another jelly bean one. So the probability of a gross jelly bean is 0.25. If you eat 3 jelly beans, what's the probability they're all good? I keep hoping I didn't put a wrong answer in this. So the first jelly bean you eat is good. And then the second jelly bean you eat is good. And the third jelly bean you eat is good. Now, when you eat these jelly beans, do you think the jelly beans care about the other jelly beans? Do you think you eat a jelly bean, the next jelly beans, you're like, that last one was gross. So, we should change what we are. No, the jelly beans are completely independent of each other. So eating one jelly bean, I'll tell Morty say, Morty! The other's saying, hey, in the chat, Morty. You need to do like bunny camera. The jelly beans don't care. They are not sentient jelly beans. We're not talking about sentient jelly beans. We're just talking about normal, what are they called? The Bean Boozled jelly beans. And so with this, the jelly beans are all independent. So the first jelly bean is good. And then the second jelly bean is good. And then the third jelly bean is good. So good, and then good, and then good. And we have class on Wednesday. Class on Wednesday, Aisha. So the first is good, and the second is good, and the third is good. Who wants to put the equation in the chat? Because we're literally saying it. By saying the first is good. Andrew, King Bowser. No, fortunately. Fortunately, yes, we have class. Nice job, Rocky Top. You got it. So this one's a little bit tricky because it's the complement. And that should be 27 over 64. So 27 over 64. Please tell me I put the right answer. I think it should be 27 over 64. Oh, you did 1 minus. That would be the probability there's at least one bad one. And maybe I put the wrong answer. I've done that before. So if you did 1 minus, to me it was, if you do 1 minus 0.75 to the third power, that would be at least one bad jelly bean. This one is just what's the probability they're all good. So the first was good, and the second was good, and the third was good. The at least one is done by 1 minus. So this is the probability that they're all good. This is the probability that what? Because either they're all good, either every jelly bean is good, or what of them? because either all the jelly beans were good or what? Just think about it, because if you do 1 minus this, you'll get this, because either they're all good or, we've got it up still here, we'll pull it up on the sheet right here. Either every single jelly bean is good or, and we can go way back in time. We did a problem very similar to it with 3 jelly beans. That's why I like doing these kind of review problems. So either they're all good or at least one is bad. Either they're all good or at least one is bad. And so I think we might not have the right mathematics in here because we changed it around a good bit. We'll go to where the mathematics was right. There we go. So either they're all good or at least one is bad. And this was a different problem with different probabilities. So either they're all good or at least one is bad. This probability right here is found where they're all good. To find the probability they're all good, we do 0.75 times 0.75. Second is good, third is good. That's the probability they're all good. And then 1 minus is at least one jelly bean is bad, because either they're all good or at least one is bad. Continuing on, leaderboard time. Whew, Bunny, no. Focus Bunny, yes. I thought they went away. I saw someone go away. Close game, close game. Who's going to win? Let's find out. With the next one, which of the following is a rule of probability? Which of the following is a rule of probability? So, which of the following is a rule of probability? Just making sure I'm out of the way of anything important. Which of the following is a rule of probability? Which of the following is a rule? It's not QQ straight enough, no outliers. Those are the rules for regression. So the rules for regression are quantitative variables, straight enough, line goes straight through the data, and no outliers. Quick timer, you're right, because the rule for probability is contained between 0 and 1. So all probabilities, the lowest probability would be 0, which means something cannot happen. No, William, no, don't misclick again. You got it, William, you got it. We're here to learn. You're going to get a lot of knowledge. And the probability 1 means something must happen. So the probability is between 0 and 1 for all events. Next question. So many people playing. Love it. Focus Bunny. No, you focus. Focus Bunny. You got this. You got this. Next question. Focus Bunny. Let's see it. Third place again. Focus Bunny. There's 9-point difference. Close game. A researcher decides to take 5-mile segments of roads and sample each 1-mile segment within. So they're taking 5-mile segments and they're sampling each 1 mile within. They're taking a whole bunch at once. They're taking a whole bunch of roads at once, and then they're doing a census on it. So that's the clue, is they're taking a bunch, and then they're doing a census of that. And they would take different 5-mile segments. They take a 5-mile segment here, and then they're doing a census. I have a feeling. Got the sad music ready. Over. I'll take it. I'll take that. Stratified or systematic and stratified usually have more. No, Alexander. So what is a cluster sample? Let's go back to our classic examples with M&Ms. I love the M&M examples. Now I want some M&Ms. But when you look at a cluster versus stratified, cluster sampling. So step 1 of cluster sampling is to items are put randomly into groups. Randomly select these groups, perform a census on the group. Stratified sampling, acknowledge a difference in the population, sample in accordance to that difference randomly. So here's the big stuff right here. So when we look at cluster sampling, how would we cluster sample M&Ms? We take a what to cluster sample? How do we, so items are put randomly into groups, randomly select these groups, and then we perform a census on the group. So you could do what to take cluster samples of M&Ms? How do we take cluster samples of M&Ms? Like what's cluster sampling M&Ms? How do we take, so we need things randomly put into groups. We're going to randomly select these groups and then perform a census on the group. Pick a bag. So we're going to take different bags of M&Ms. Bags are clusters of M&Ms. How do we, but wait. Because color, if you say by color, then you're going to acknowledge a difference in the population. So when you do color, that would be acknowledging a difference because M&Ms are different colors and maybe we're looking at like defects or something. So it could be colors is stratified because you're bingo right there. Exactly. So we have right there the different stratified. and cluster, but how could we cluster sample soda? Like you work for the Coca-Cola plant, and how could you cluster sample soda? How could you do a cluster sample of soda? So items are randomly put into groups, randomly select these groups, and then perform a census, which means take data on everything in the group. So how could we cluster sample soda? Any ideas for cluster sampling soda? Buy a 6-pack. So 6 packs would be cluster sampling. Take 6, and we take multiple 6-packs. So to be specific, you would take like 10 6-packs randomly throughout the factory. So you would go and say, we need 10 random 6-packs. Does that make sense? That would be different clusters of Coca-Cola. So 10 random 6-packs. And then how could we stratify Coca-Cola? How could we stratify sample Coca-Cola? How could we stratify sample Coca-Cola? Any ideas for? So by flavor, by like diet or regular. So we'd say, okay, we need to sample so much of diet, exactly cherry, Mountain Dew or Coke, acknowledging a difference right there. So this is when we stratify and we say, okay, we need to sample this portion from the Coca-Cola and this portion from the Mountain Dew to make sure we get a proper representation of our factory. So that'd be a stratification example right there. So big stuff, stratifying versus clustering. Pretty good work on this question. Let's see what people do right here. Focus Bunny, I'm sorry. Don't. You got this. You got this. If Focus Bunny leaves, I'll have to pick a new favorite. So let's see what the next question. Who's gonna win? Who's gonna win? Ah, yeah, Alexander saw it's not just verifiable. Researcher selects their sample based on the percentage of highway, country, and city roads. So they're gonna say, I need this many highway roads, I need this many country roads, I need this many city roads. So they're gonna make sure they get the right percentages for these differences in the population. So it's like, you know, they're trying to understand potholes, hints for later questions. And so with that being what they're trying to understand, they say, well, maybe there's differences with these roads. So we need to make sure we have a proper representation in our sample for the highway roads, the country roads, and the city roads. So if they're acknowledging a difference, they're definitely doing yes. Great review right there. So definitely it's not convenience because that'd be getting the first roads near them. And then random sample would be if they just randomly take roads they could pick random road segments to pick. But I think people are getting it and they see the difference between stratified and clustering. Really good to use note cards for this and just to do different examples. But this all comes down to just review of concept. Oh no, you got this. You got this. I'm sorry, Focus Bunny. I'm sorry. We're going with Knowing Zebra. Knowing Zebra, I can't go wrong with Knowing Zebra. Knowing Zebra, let's see this. Focus Bunny, I want to see you appear back. Hop back onto the leaderboard though. You got this. With the next question, a researcher selects the first 20 roads near their house. Everyone's got this one. I don't want to see anyone get this wrong. I'm not even going to say anything. Everyone's answering in. I want to see so many right answers. I know, right? We totally got this. I'm just going to hit the microphone. Totally got this. Because getting the things that are closest to you or nearest to you, the things we have easiest access to, sounds very, very convenient. Convenient. Some people might have been trying to click there first, but I'll take 88. So it's very convenient right there. This is the first things we have access to, the easier things to get data on. Who's going to be in the lead? Leaderboard. It's so interesting how the leaderboard gets so locked up. The leaderboard gets like, after 10 questions or so, the leaderboard pretty like jam-packed. Let's see. Smiling Elk and Knowing Zebra in the lead. Can they hold on to it? Question number 10. A researcher selects every 5th road on the listing of roads. Every 5th road is selected. Oh my gosh, look at all those answers. Every 5th road is selected. Everyone knows what this is. This is when you pick a random starting point, which is kind of ideal for it. You pick a random starting point and you select every kth observation. So the definition of this, it's stratified, is you select every kth observation, or oh my gosh, you start at a random starting point, you select every kth observation, which can be the 5th, the 10th, it can be any sort of kind of separation between the data. Great job right there. Another great answer response. Loving it. Excellent review. Leaderboard is locked. Leaderboard is just, I don't know who's going to win. I'm going to go over here a little bit more. Maybe I won't be in the way if I'm over here. Let's do this. Let's do the next question. A researcher lists all roads and randomizes them and then selects the first 50. This was on a test one time and people got it wrong. So they're going to first randomize the roads and then select the first 50. A lot of people put something that was not. So they're going to randomize all the roads and then select the first 50. And the key right here is that they've randomized them. So if the first 50 they selected would be what? The first 50 they've selected would actually be random. So it wouldn't be convenience. Not many people put convenience, but it'd be random because the first 50 they would select would be a random set of 50 roads. So this right here is an example of simple random where everything has an equal and likely chance of being selected. So even though it's the first 50, they're random. So they've been random. There's random right there. I love it. Nice job, Andrew, in the chat. So they've been randomized. So the first 50 roads would still be 50 random roads. Next question. Smiling Elk still in the lead. Great job. The researcher takes too many city roads. Now we're to bias. So with this right was a pretty good joke. With this right here being different biases, they take too many city roads. So we have response bias, which is when the question kind of leads to a response that is biased. We have convenience bias when you go out and take a convenience sample. We have non-response bias when they can't get to things, hints for later questions, or things just don't respond. You can't get data on stuff. And this would be under coverage. So they didn't get enough of the other roads. So if they take too many of one type of road, they would get too few of another. So under coverage is when you don't, like, if we have a classic example, we say, go ask, the Green Party who they're going to vote for. And you're like, wow, the Green Party candidate's going to win. And the issue is you have a biased sample. You're undercovering the other political parties. Oh no, I know, right? Yeah, we did get a lot of timeouts. We got this. We got this. No, that's all right, Joseph. We're going to see who's in the leaderboard lead. Focus Bunny is back. Focus Bunny is back. We got this. Focus Bunny. Make sure to email me whoever wins. Send me the picture of your win. The researcher is unable to get information on certain roads. The researcher can't get information. You got this, Joseph. You got this, Joseph. The researcher cannot get information. So think about this. What kind of bias is this if they can't get data? It's like calling the phone and someone hangs up. It's like going to collect data at a house and people don't answer the door. So what is this right here? This would be non-response. I pause on the ones where people get them more wrong, but non-response is when people or items don't give a response to the question. Brian, yeah, I've got my phone. I'm just like, it'd be so interesting if I played. It'd be so interesting. I wonder if someone would beat me. These are my own questions. So I don't know. Am I Smiling Elk? Bunny keeps going away. Bunny, stop doing that. Bunny, stay in the lead. I mean, beat Smiling Elk. Smiling Elk, Knowing Zebra is only 100 points behind them. So it's neck and neck between Smiling Elk and Knowing Zebra. Let's see right here. No, you got this, Andrew. You got this. Question 14. The list of the roads the researcher has access to. Ooh, this is going to get a lot of people. These are the ones they can sample. Theoretically, any of these roads could be sampled. So these are the theoretical things they could have in their sample. So what do we see right here? These are the theoretical things they could sample. It's not what they do sample. It's not what they're interested in. And it's not the group they're interested in. This is going to be a shakeup of the leaderboard. I know it. Oh, nice job. People really know their stuff. Must have a good teacher. So I'm really impressed. It is the sample frame because these are the roads they have access to, and what they could possibly sample is the sample frame. So the sample frame, total awesome. So so what's the difference between sample and sample frame? So the sample would be the roads that the researcher actually samples or the ones they collect data on. I think I might have misworded the question. Well, thank you, Brielle. So the sample would be the roads the researcher collects data on. The sample frame would be the roads that they could collect data on. So if you go to Hodge's library to talk to people, wear a mask. And so if you were to go to Hodges Library and talk to people, everyone in Hodges Library at that time is probably in your what? Everyone who's walking around in Hodges Library is probably what? So everyone, because why? And think about why would they be this? Everyone walking around in Hodges Library is probably your sample frame because you could possibly talk to them. It's like I could talk to anyone in Hodges Library, so they're in my sample frame. Everyone you talk to would be your sample, as long as they give you information. They don't give you non-response bias. The population would be maybe you want to understand all UT students, and then the parameter of interest is what do you want to understand about them. Maybe you're asking them, how many hours a semester do you spend in the library? So the question you ask them would be the parameter of interest, and then the group you're interested in talking to is the population. Does that make sense? So the population might be all UT students, and the parameter of interest might be, whether or not, how many hours they study a semester in the library. Continuing on, leaderboard time. We see right here, Smiling Alex still in the lead. With this, next question, the roads the researcher samples are the ones that get data on. That's a better way of putting it. Response bias would be something, it's really hard to write for these questions, but response bias would be something like, they like write a biased question about the roads. I can't even think how to do that. What would it be? I'll vanish. So with this question right here, we see the roads that the researcher's samples would be the sample. Does the Kahoot cover a lot of topics? Not all of them. So the Kahoot covers a lot of the topics, but not every single one of them. But the road, I thought this was a pretty easy one right here. Took a little break from the question for a moment. So would be the population be this? So that would be the population for this type of sample. Expand upon the question, Gigi, I think. So this right here would be the ones they actually get data on, and that would be the sample. So great job right here. The leaderboard is so locked. This is craziness right here. Next question. Let's do it. The roads the researcher wants to... Ooh, Andrew, you might be on the right track. For the non-response bias question, wouldn't it be in a way also be undercoverage bias since some portion of the population is not sampled? So if you don't have access to a road, then it would be... I would say that's non-response. It's hard to classify everything perfectly, but you can't get information on them. And in that instance, we just can't get a response from them. Where under coverage is when you would try to sample these things and you can't. It's hard to... The under coverage would usually be if they set up their sampling the wrong way. Oh, no! You have some wrong answers here. Oh, wow. The roads the researcher wants to understand. Well, wait, what is the difference with parameter interest? It wouldn't be the roads they want to understand. It wouldn't be the roads they want to understand. It's what? The parameter of interest wouldn't be the roads they want to understand. What's a keyword for parameter? It's something. It's a 4-level word. So what about the roads they want to understand? Yes, exactly. So what about the roads? What are they wanting to understand? This is what do they want to understand, and this is the group they want to understand. So the researchers want to understand the roads, but if it said what about the roads the researcher wants to understand. So does this make sense? The parameter is what you're measuring. So they're not measuring the roads, they're measuring something about the roads. The roads are the population because that's the group they want to understand. And then whatever characteristic they're measuring about the road is the parameter. Does that make sense what a parameter is? The parameter is whatever characteristic they're trying to understand about the population. The population is the roads because that's the group of the thing they're collecting data on. So I think, is everyone good on that one? The parameter is the what they're trying to understand about the roads, like what characteristic. Imagine this. You go to a UT football game and ask people how much they are spending on souvenirs at the game. So what is the population? You go to UT football games and ask people how much they spend on souvenirs. So what is the population right here? What would be the population? You go to UT football games and ask people how much they spend on souvenirs. People at games. You could say people at... The sample frame would be people at that game, and then the population might be people who go to UT games. Does that make sense, Florence? So you might be like, we're trying to understand UT fans, so we took a sample from a game. So the sample frame would be people at that game, and then the sample would be the data you have, and then the parameter of interest would be how much do you spend on souvenirs, because that's what we want to understand. So the sample frame, or excuse me, the parameter of interest would be how much do you spend on things, souvenirs at a game. We might have a question trying to clarify this. Let's take a look right here. Ooh, winged mouse and happy goose. Knowing zebra and smiling elk are just destroying it. So parameter of interest is basically the research question. Exactly. Parameter of interest is whatever the data question's going towards. Great job. Nice job right there, Victoria. Trying to combine your knowledge. Love it. The researcher is collecting the average amount of potholes per mile. Winged mouse. Winged mouse is so cool. Let's call winged mouse in the upset. Winged mouse, you got this. The researcher is collecting the average amount of potholes per mile. That is what they're recording data on. So whatever they're recording data on would be the what. We were just reviewing this. We do a lot of review between the questions to make sure we know them. So when we see it again, we're like, you have to review stuff. You have to do questions 2 or 3 times to make sure you know that whatever they're collecting data, like the information went on, is the parameter of interest. Great job right there. We lose people during the game. Mauser. Is there a mouse Bowser? Oh, yeah, of course. Is that from Paper Mario 1,000 Year Door? I think it is, right? Or one of the Paper Marios. So how is it not the sample? The researcher is collecting the average amount of potholes per mile. So the roads they collect data on would be the sample. So with this right here, this is the data question they're asking. They're asking how many potholes are there per average per mile. So this is going to be what they're interested in understanding. And then the roads would be the sample. So the sample wouldn't be the data itself, like the numbers in the data. The numbers go more towards the parameter, but the sample would be the roads they collected. Like the roads were our sample. We're trying to understand how many potholes there are per mile. So whatever we're trying to understand about the roads would be the parameter. Yeah, GG, great questions. You gotta work it out. GG, 1,000 points. Keep it up. 1,000 Year Door throwback. Yeah, 1,000 Year Door is such a good game. There's people who do crazy speedruns of that game. Smiling. Like, there's a really cool video. Like, what happens if you hit this block 1,000,000 times? Go watch that video. It has to do with numbers and stuff like that. I wish I could pull out game facts like that. It's playing too many video games. There's too many. I gotta play Hades though. Looks so good. Thank you for the suggestions, people in chat. Probability of making a shot is 0.30. What's its complement? Easy question. Easy question. Let's see. I want to be pressing. I want to press that button after this. No such thing as too much video games, I think, right there. Hey, what's up, Colin? So good to see you here. 5-hour interview today, Brian. Just finished. Hey, see you at 8 a.m. And I hope that interview went great for you. I hope so. You have to tell me about that interview. You have to send me a message and tell me how it went. Good luck. 5-hour interview. You could take a 5-hour energy. That's so lame. Worst joke ever. So 0.30 is the complement of 0.70. So a lot of people ask me, like, if P is equal to... Good question right there. 0.8, what is Q? Q is equal to 0.20. P and Q are complements, and P hat and Q hat are complements of each other. So make sure you know how to find the complement of something. Very easy to do, just you have to know it. And once you know it, you should have it. Continuing on to the next question. This is insanity. I don't know who's going to win. It's really close. 109 points separate people. Let's see here with the next question. The law of averages is a fallacy. The truth is what? I need to go away. I was blocking part of one of the answers. So the law of averages says that if something happens in the past, like you flip heads 50 times, you'll be more likely to flip heads on the, or less likely to flip heads on the next one. What we're talking about is past events do not influence independent trials. Oh, people kind of knew because they're like, he's blocking one of the two. Two events can be multiplied together. That's a true statement. But when we talk about the law of averages is like, I've been losing a whole bunch at poker. I'm due for a win. Do the cards care that I've been losing? So when you think about the law of averages, people go to Vegas and they're like, I've been losing so much, I'm due for a win. That is the law of averages. That is a fallacy. It's fallacious thinking to think that independent trials will be influenced by each other. That when you get your cards on the next hand, is Mouse winning? I wish the cards cared. I wish the cards cared too. We were watching a Resident, and they're betting patients. Oh, winged mouse. Winged mouse. It's first and second are having a run off. Second and third and fourth having a run off. Who's going to win unless you're counting cards exactly? Then there'd be a different probability, and that's the whole thing of counting cards. Nice job right there, Joseph. Yeah, because counting cards will help you know the probabilities. Who's going to win with question 20? We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is P hat? Ooh, quick question. What is P hat? Oh yeah, 21 is great. What is P hat right here? We know UT is 20% freshmen. We sampled 200 students. 30 report being freshmen. What is P hat? So this will help out, but think about what 20% would be if we know that. That would be P, and that'll help for a later question. Some people put 20. Now remember, 20 is P because we know it. Remember this. P is the true proportion. P hat is the sample proportion. What is the equation for P hat in the chat? Because you need to know what 30 is, and you need to know what 20 is. So what is the equation for P hat? What is the equation for P hat? X over N, exactly. So 30 over 200 was the answer. It's the amount of successes over the number of trials. A little bit more review questions here. It's all coming down to notation. Oh my gosh, winged mouse going way up right there. And wow, leaderboard just shake up. Let's see right here what happens next. In this question, do we use, you'll use 3 conditions right here. What is the sample size? Easy question right here. Oh, you did. Oh, then you got 60. And so what is the sample size right here? What is the sample size going to be? Love the chat. The sample size is going to be what? Everyone should know sample size instantaneously. So make sure you know what N is. N is sample size. It'll help with your equations. And the sample size right here is 200. Easy questions. We'll get back to some hard questions here in a second. But is the leaderboard changing? Leaderboard's not changing. Leaderboard is still locked. Let's see the next question right here. Who's going to win? What is P? I shouldn't have wrote so many of these. And then I give away half of them. I think I might have done one more. I shouldn't have written so many of these. There are too many repeat questions. But you should instantaneously know what P is. P is the true proportion. Q is the complement. Just what is Q? P is the truth, meaning that we know this. So whenever we say we have P, that means we know the true proportion. And what is the true proportion for this? The true proportion is... I want to see 100% get it. We never get 100%. No! Some people put, this is X, which might come into play here. How am I going to stump Smiling Elk with these questions? I know we need some harder ones, Thomas. We'll get some harder ones coming here in a second. Do we do X next? We might do X next. But let's take a look. Wouldn't it be so crazy if Smiling Elk just fell off the leaderboard right there if they went down? You'd be like, no way. Here we go with the next question. Let's see right here. Next question. UT is 20% junior from 80 students, 30s are junior. Find the mean of the sampling distribution. Ooh. So we know UT is 20% junior. What is the mean for the sampling distribution of the sample proportion? We know UT is 20% juniors. And then there's 80 students and 30 are juniors. So what is the mean for the distribution of the sample proportion? Oh, wow. If you know this one... Oh, we tricked so many people. It sounds difficult. This question sounds very difficult. But this question right here is just this. The mean for the distribution of the sample proportion is just what? So when you have your formula sheet and you hear the mean for the distribution of the sample proportion, it's just what? So the mean for the distribution of the sample proportion is what? It's simply what? Someone type it in chat. The mean for the distribution of the sample proportion is simply this. All it is this. It's just P. So let's take a look at the question. UT is this. So the mean for the distribution of the sample proportion is just that. Does that make sense how we figured that one out so quickly? So if you know UT is 20% freshmen, in a sample, you'd expect to see 20% juniors right here, 20% juniors. We know UT is 20% juniors. So in a sample, we'd expect to see 20% juniors. That's what that means. If you went out and sampled 80 students, how many of them would you expect to be juniors? If you went out and sampled 80 students, how many of them would you expect to be juniors? How many is the question? It's a decent question right here. How many? 16 exactly, Florence, because you'd expect 20%. Because you're saying I would expect there to be, so the difference between sampling distribution is theoretical, and it's what could possibly happen. So when we have the theoretical what could happen here, we're saying if UT is 20% juniors, then we would expect to see 20%. We'd expect to see a standard deviation of the following. Oh my gosh. And so, and from this, taking a sample of 80, we can draw the what distribution right here. So this is what a sampling distribution is. Sampling distribution. The sampling distribution says to us that we'd expect 20% juniors, but we would see variation in it. The variation comes from the standard deviation, but you can't guess what the next question is. And so the variation here comes from the standard deviation. So the standard deviation is going to be the variation in what you could possibly see in a sample. You'd expect 20%, but you could see variation around that. So it's saying, theoretically, if you take a sample of 80 students, what percent of them would you expect to be juniors? And we would expect 20% because we know that's the truth. And then we see here the variation around it. So I had 22 answer streak. Oh no, I'm so sorry, Marissa. And you were in the leaderboard, right? Were you winged mouse? I'm so sorry. Let's continue on. What do you use P hat and P? So P hat is the sample proportion and P is the true proportion. So when we look, we'll look at the next question here and I'll explain. Find the standard deviation. So we need to do P times Q over N square root. Be quick on your calculator. P times Q over N square root. Winged mouse still has a chance. Winged mouse is you. Everyone's rooting for you right there. P times Q over N square root. So P is the true proportion, which you know. And then this right here is N, and this is X. So this would be the sample proportion because X over N is the sample proportion. So when we have X over N, it's just going to be the amount of successes over the number of trials. And that right there will give us the sample proportion. We got the full 60-second question right here. So this question right here, we'll solve it on the calculator while it's going on, is going to be P times Q, which are complements, over N square root. There we go. Should be the blue answer. Click in real quick if you haven't. P times Q over N square root. And that's got it. Great job right there. Review of how to do the standard deviation for the distribution of the sample proportion. Winged mouse, are you back? Silver ostrich is here, but it's a close game. It's a close game. So let's continue on. See who's going to win. We've only got 3 more questions left. For the sampling distribution of the sample proportion, what is the third condition? So there's really no order of the conditions, but we say condition 1. I shouldn't have done that. Random. Condition 2, less than 10%. And now condition 3, I have 2 conditions on here which you might be picking between. It's important to pause when you get to condition 3. People might be saying pause in the chat. When you get to condition 3, there's 2 choices really. We really have one related for categorical data and quantitative data. And it is success failure. Success failure means there's at least 10 successes and at least 10 failures. So if we have a sample size of 80, how many expected successes would we have? With a sample size of 80 and a P equal to 20%, how many expected successes would you have? With a sample size equal to 80 and a P of 0.20, how many expected successes would you have? 16 exactly. And then you would have 54 expected failures. So 16 expected successes, and so it would be N times P greater than or equal to 10. Does that make sense, Joseph? And that would be 80 times 0.20, which is equal to 16. And then you'd make sure that NQ is also greater than or equal to 10. So both of those need to be greater than or equal to 10. And since they are, we pass the success failure condition. Now, random means that we randomly select our data. 10% means we have less than 10% of the population selected. Oh, no, Joseph, you're fine. Ask the question. Someone was probably wondering watching this video. And people get confused on the less than 10% condition. So 10% means we select less than 10% of the population. I can't say that enough, that we select less than 10% of the population. Make sure to do less than 10%, not more. I know it's confusing, but it's less than 10%. This is neck and neck leaderboard. Smiling Elk and knowing Smiling Elk has just been running away with it. Let's see who's going to win. 2 more questions to go. Ooh, this is a random question. So heads are 0 through 4 and tails are 5 through 9. So there's the random numbers. What percent of the time do you get exactly 2 heads? So you need to realize that heads are 0 through 4. So this is a heads, 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 and then this is also heads. So we want to see exactly 2 heads. So what do we have right here? Here's a heads, and here's a heads. So we have here heads and heads also. We see this, and then what do we see right here? Let's see, this is going to be heads right here, and 2 other heads. So in these trials right here, there's another trial, and we have 3 heads right there. In this trial, we have a heads here, we have 2 heads here because there's 0 through 4 numbers. So there's 3 heads in this trial. And in this trial, we have heads, 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 all heads. So as far as I can tell, this is the only trial where we got 2 heads. You only have a character limit on this, so I try to type it. There it is right there. Great job. Great job. So there was only 1 trial out of 5 where we had exactly 2 heads. Who's in the lead now? Who is in the lead? Winged Mouse. Was it Winged Mouse? Yeah, Winged Mouse is back. Be quick. It asks for percent, but only gives probability. Oh, whoops. Sorry. So I clicked the wrong one. No. 22nd place ain't bad. That's right. That's right. Not bad. Last one right here. Let's see who's going to win right here. Here's the last one. What percent of the time did you get exactly 2 tails? So it's the same data, but now we want to look for exactly 2 tails. So if we look right here, tails is 5 through 9. So here I see 1 tails. Here I see how many tails? 3 tails. Let's slow down. I don't want to get the question before everyone gets it. Let's look at this one. Remember, this one was the 0 tails. We have no tails because they're all heads. So let's look at this one. Right here, we see tails, heads, tails, heads, heads. So I see 2 tails right here. That's exactly 2 tails. So that's 1 trial. And then a trial right here. We have tails, heads, heads, heads. So in both of these trials, we have exactly 2 tails. And there's 5 total trials. And with 5 trials, that is 2 out of 5 trials. 2 out of 5 trials. So what is the percent of time or the decimal? It is 40%. Nice job. Nice answers. No worries. Who do you think won? Do you think Winged Mouse got up there? I want to see Winged Mouse on that leaderboard. Let's find out if Mauser's there. Is it going to be, was it Shining Elk all the way? Let's find out right here. Let's turn up that music. Let's go see who wins. 3rd place. Stellar Condor. Nice job, William, right there. Knowing Zebra and everything correct. Smiling Elk. You know what I'm really interested in? For all top 5. Maybe we'll do that for the final. And please tell me, a lot of people tell me these Kahoots help them out. It's very interesting to see the winners of the Kahoots often do extremely well in the test. It's usually, these types of questions are multiple choice. Good game, everybody, and really great job to the 3. Amazing job getting everything correct. That is super impressive. I'm really astounded. But, if you have any questions, let me know. The exam will come out tomorrow night at, I believe, 6 p.m. I'll send out an announcement reminder. It'll be open until 9 p.m. the next day, so Tuesday through Wednesday. So get ready for the exam. Please tell me if there's any issues. Please tell me if there's any issues. And make sure to email me Smiling Elk, Knowing Zebra, Stella Condor. Send me a screenshot of your stuff. Everyone wants to know who Smiling Elk is. Knowing Zebra. Just Mr. Prize. No, Andrew, so close. Is anyone here who's on the leaderboard Knowing Zebra, Stellar Condor? No, I didn't make it. I was having trouble making it because it's just really bad for importing questions there. Sorry, Alexander, I haven't made it yet. I was also grading this weekend. Sorry about that. It crossed my mind, and I was like, I just run out of time sometimes. You were focused, Bonnie? No, you're on the leaderboard. I love everyone in the chat being like, reveal yourself. Who is this person? We will find out. I will find out. Make sure to email me. Send me a screenshot. We'll feel like a random person who joined our class. Oh, you're welcome, Alexander. I appreciate it. Appreciate the positivity. It's maybe I'll take another look at it tonight. Elka Beasto, totally. At Smiling Elk, who are you? Any other last questions before we get going right here? Any other last questions? You had a good competition with Mauser. Love it. Awesome stuff right there. Amazing work today. Really good practice. You did not fail me at all. You know what? Here's the thing. If you don't do well on the Kahoot, or you don't win the Kahoot and you do well on the test, that's what matters. So what really matters here is that everyone had a good time studying. Few people got some prizes, but overall, the big point is study for the exam. Use the review videos. Has everyone seen the links that we have for the review videos? Let me go ahead and post some links in chat here again. But make sure you're studying. That's going to be the biggest thing right here, because really it comes down to going over the material, finding out what works for you. And if the videos help you, that's great. If going through the practice test helps you, that's great. But going through and finding just a way to learn the material, or way to practice it, not learn it. Hopefully by now you're practicing the material, not learning it for the first time. There we go, right there. So there is review videos in the chat. But let's see. Any other last questions? The test doesn't matter how fast you answer. Exactly. Thank you very much, Andrew. So much positivity. I didn't do.
I'm Dr. Amy Allen. I have my own medical practice,
random
and I've been using
YouTube video in the background. You guys probably heard it, me too. Because there was a random ad. So I didn't do speedruns for test 2, but I do have the practice videos posted. So go check out the practice videos. I just didn't have time this weekend. I kind of overdid at the start of the semester with all the videos. So taking a little more time to relax. But we don't have the speedruns for test 2. They might come back for test 3, but I do want to make speedruns of every chapter and have a more concise way. You're welcome, Kobe. So good to see you here. Hopefully everyone had some fun. Let me know. Little extra Mario for Brian this time. Yes. Let me know if you have any questions. I'll be answering all the emails. With that, I think let's end with some really happy music. I love the between music bumpers. So we're going to have some really happy music. So take a moment, chill, relax. Stat to a 1. Talk to you later. Bye, everybody. Thank you, Thomas. You're awesome.